Today we'll focus on two things only. We'll focus on rational functions and radical functions. Specifically, we'll talk about how to find the domain and range for the rational function, how to find the intercept, how to find the domain, oh, I've already said that, the vertical, the horizontal asymptote, and also how to sketch. There we go. Question 17 from tutorial sheet 4 is talking about rational function. Sketch the graph of the following, clearly indicating all the intercept and asymptote. You can't sketch without showing the intercept. You can't sketch without showing the asymptote. Get me right there. For a rational function, you can't sketch without finding the asymptote. You can't sketch without finding the intercept. As simple as that. We okay? Now, I'm going to be moving step by step. If you have got a question, just ask. Don't bother yourself, just ask. Okay? There we go, guys. We start with the first question. So we'll start with how to find the intercept. How do you find the intercept? So intercept, you have got what we call the x and y intercept. To find the x intercept, equate y equal to 0. So for x, meaning that this function here, it is the same as that function is y is equal to negative 4 over x minus 2. Where there is y, equate equal to 0. So I'll say 0 is equal to negative 4 divided by x minus 2. Make x as a subject, find the value of x, that is the x intercept. Here there is divided by 1. If I cross multiply, I'll have negative 4 is equal to 0, because 0 times everything here is going to be 0. Once I come across this situation, negative 4 is equal to 0, it's not true. Again, x is not existing there. There is no x here. Therefore, for this function, we have got no x-intercept. So you say no x-intercept. Is that okay? Then I need to find the y-intercept. How do you find the y-intercept? The opposite is true. To find the y-intercept, equate x equal to 0. The function is y is equal to negative 4 divided by x minus 2. Equate where there is x, equate equal to 0. So negative 4, 0 minus 2. So have 2. Meaning that the y-intercept is at y is equal to 2. Meaning that when x is 0, y is 2. That is what we have only. Okay? So you are done with the intercept. Who has got questions here before we go to asymptote? Any question? Okay, everything is super. Next, we need to find the what? We need to find the asymptote. How do you find the asymptote? There are three scenarios. Now, there is what we call horizontal and vertical asymptote. To find the vertical asymptote, get the denominator set equal to 0. So for x minus 2 is equal to 0. So for x is equal to 2. My vertical asymptote is at 2. Is that x is equal to 2, in short. Is that x is equal to 2. Now, when it comes for the domain, when you know how to find the domain of the rational function, that is the vertical asymptote. In a case where I want to find the domain here, we just say x minus 2 should not be equal to 0. So for x should not be equal to 2. That is the domain. Have you seen the relationship which is there? When you're finding the vertical asymptote, just say get the denominator set equal to 0. So for x. When you are finding the the vertical asymptote, you just equate equal to 0. So for x, when you're finding the domain not equal to 0, so for x. So the domain and the asymptote is the same, only that the other one we're going to say not equal to that. We are good to go. Now, the way we find the horizontal asymptote, horizontal asymptote, guys, you check the function. This function which you have here is bottom heavy. The degree of x on the denominator is higher than the degree of x on the numerator. Therefore, the horizontal asymptote is 0. Horizontal asymptote is the same as the range. In this case, since the denominator has got the highest power of x, we say that y should not be equal to 0. So the horizontal asymptote in this case is 0. Now, in a case where, like this one here, the denominator and the numerator, they have got the same power of x, then I have to divide the coefficient, negative 2 divided by 1. In that case, they are not going to give you a scenario where the numerator has got the highest power of x than the denominator. Then they ask you to find the range. You understand? So now, in this case, y is equal to 0. When you find the vertical asymptote and horizontal asymptote, then the rational function sketching becomes very, very, very simple and straightforward. The only thing you have to do now is just to have your comma simple sketching. Okay. The sketching which you have, the first thing is put the asymptote. The first asymptote which we have, guys, is at x is equal to 2. X is equal to 2, I'm going to put it here. So the graph should not touch this line. That is my asymptote. You understand? Again, the horizontal asymptote is at y is equal to 0. So this line, the graph should not touch this line. Done. After doing this, put your intercept which you have. You have got 0, 2 in x0, in y2. So in y2. So where do we expect that to be? It's here. When you click, when you make a point there, guys, meaning that running away from the asymptote, touching this point, again here running away from the asymptote, coming closer to the asymptote. You put the arrows, you don't know where the graph is ending. When you do that, the opposite of this part here has to be reflected to the other side, which is this side. Then I have to put another point like that. Meaning for the first part, and most of the cases, this question is 5 marks. Meaning you have gotten 5 marks, unless you have got questions. Do you have questions? Yes. Let me explain, sir. So I'm going to explain this, and then I think you understand when we do question 2. So the horizontal asymptote, let's talk about the horizontal asymptote. There are only 3 scenarios about the horizontal asymptote. For example, the way this function is negative 4x minus 2. On top, I don't have any x. This function is bottom heavy. The degree of x on the denominator is higher than the degree of x on the numerator. Okay? Then we say the function is bottom heavy. Okay? Is that okay? About bottom heavy? Okay. So now, what we'll do is this. This is what we call the bottom heavy. If the function is bottom heavy, the horizontal asymptote is 0. Even when it comes for the finding range, then you just say y should not be equal to 0. If the function is bottom heavy, the denominator has got the highest power of x than the numerator, then definitely the function is bottom heavy. Okay. Next, if I have a function which is like this, like the second one here, 6 minus 2x divided by 1 minus x. On top here I've got x to the power 1, down here I've got x to the power 1. So the degree of the powers of x on the denominator is the same as the powers of x on the numerator. Therefore, you just divide the coefficient. So you say the horizontal asymptote will be equal to negative 2 over negative 1, the coefficient of the x. So the horizontal asymptote in this case, you say it is 2. If you're finding range, in this case you say y should not be equal to 2. As simple as that, if that is the range. But since we're interested, we're not interested in the range. We are interested in what? Horizontal asymptote. Does that make sense? Does that make sense? So let's now do part 2. I said the first thing is to find the intercept. After intercept, find the horizontal and vertical asymptote, then sketch. So let's first find the x-intercept. Do we expect to have x-intercept equal to y equal to 0? So that will be y is equal to 6 minus 2x divided by 1 minus x. Then where there is y equal to 0, 6 minus 2x divided by 1 minus x. Cross multiply. So if I cross multiply this times 1, it will be 6 minus 2x is equal to this times 0 is 0. So it will be negative 2x is equal to negative 6 divided by negative 2, negative 2, x is equal to 3. Meaning that my x-intercept is at x is equal to 3. When x is 3, y is 0. That's what we have said here. Take note. We are done with x-intercept. Y-intercept, x has to be 0. Then you say y is equal to 6 minus 2x divided by 1 minus x. Where there is x, put 0. Y is equal to 6 minus 2, 0, 1 minus 0. So y will be equal to 6 divided by 1. Y is equal to 6. When x is 0, y is 6. Like that. For the intercept, I'm done. Who is behind on how to find the intercept? Negative 6 divided by negative 2. Not okay. You are okay all the way from this point here, right? Even here you are okay. Are you sure? Wow. Nice. So now, after finding these intercept, then find the horizontal asymptote. Now I'm going to be asking you, if I want to find the vertical asymptote, what did I say? What do we do? It's high time now I start knowing people. Sorry, you are even here. Um, Mildred, are you guys getting me? Sorry, are you getting me? Okay, now, no, I didn't say anything. I didn't say anything. I just asked you to say we are now on question 2 and I'm asking you how do we find the domain, sorry, how do we find the vertical asymptote in that case? Uh-huh. Okay, yes, that's what I said. 1 minus x is equal to 0. We solve for x. X is equal to negative 1, meaning x is equal to 1. So my vertical asymptote is at 1. What of the horizontal asymptote in this case? What is our horizontal asymptote? If you really understood what I said, what is the horizontal asymptote? Y2. So we are dividing negative 2 and negative 1 because the numerator and the denominator have got the same power of x. Not so. Hmm? Sorry. My question is the horizontal asymptote. We are trying to find the horizontal asymptote. Now my question is our what is our horizontal asymptote in this case? Since the numerator and the denominator has got the same highest power of x, then we get the coefficient, we divide. So neg 2 divided by neg 1 is 2. So our horizontal asymptote is 2. Are we okay on how to find the vertical asymptote and horizontal asymptote? Sketching is not hard. Why are you not okay? Hmm? Okay. So it's the same issue with question 3. So I think you understand on question 3. So now let's sketch this. First, we need to identify where the vertical asymptote is. Vertical, we're talking about this line. Horizontal is this line. So vertical is at 1. I'll put 1 here. we put a dotted meaning the graph can't touch this line. Horizontal is at 2. I'm going to put a 2 there. Again, it can't touch that line. Next, put now the intercept. The intercept which we have is 3, 0. In x3, I'll put 3 here, 0, which is here. Okay, another one is at 0, 6. 6, let's just put it here. So it will be there. This is one thing where, wait, the moment you see this point, meaning that the graph has to start from there, touching the intercept, then going there. You put the arrows because you don't know where the graph is ending. Again, here you start from there, here, it touches there, it goes there. Then you put the arrows, you don't know where the graph is ending. Here there's nothing like reflecting because you have got the intercept for both x and y. So it will reflect on its own. So that's the graph of the second one. Unless you have questions. Unless you have questions. Okay. No questions, we go to the next one. Yes. Sorry. Have you just joined now, or you were there when when we were starting? Okay, so I said the domain is the same as the vertical asymptote. The range is the same as the horizontal asymptote. So if you have been asked to find the domain, meaning this is your domain, so you just say x will not be equal to 1. If you're finding the range, y is not equal to the horizontal asymptote, which is 2. So the domain is the vertical asymptote. The range is the horizontal asymptote. Is that okay? So I'm going to do the third question. The fourth one, you are going to do it yourself. So the intercept, the x-intercept, y should be 0, meaning 0, 1, 4x, 1 minus x, which we know that is going to be 1 minus 4x is equal to 0. Negative 4x is equal to negative 1. X is equal to 1 over 4. So my x-intercept is at 1 over 4. When x is 1 over 4, y is 0. Done. How do we find the y now? X has to be 0. So it will be y is equal to 1 minus 4, 0, 1 minus 0. Y will be equal to negative 3 over 1. Y will be equal to negative 3. Meaning that when x is 0, y is negative 3. Those are the intercept. Then find the horizontal asymptote. To find the horizontal asymptote, get the denominator, set them equal to 0, solve for x. 1 minus x is equal to 0. Negative x is equal to negative 1. X is equal to 1. So the horizontal asymptote, so the vertical asymptote is at 1. The vertical asymptote is at 1. We are together. Anyone who is behind already? Anyone who is behind already? Now let's find the vertical asymptote. The vertical asymptote, sorry, the horizontal. The function is not bottom heavy. The degree of the x on the numerator and on the denominator are the same. Then what do we do? What we do in that case, we just get the coefficient negative 4 divided by negative 1. So it's 4. So the horizontal asymptote is 4. Done, right? Then we sketch. The one who was asking, I don't know if you're now okay. So the horizontal asymptote, the vertical asymptote is at 1. I'll put it here. Next, the vertical asymptote is at 4. I'll put 4 here. Then 0 comma negative 3 in y negative 3, I'm going to put there, meaning this is the point. Then, and here, you know, sometimes some of these things, even if we have not solved the so we can be able to know where this is. Not so. So we are saying the vertical asymptote is where now? 1 over 4. 1 over 4 is here. So meaning another point is there. But this graph, why did we find negative 3 here, if I may ask? Yeah, I think we made a mistake. Let's redo it. We are finding the y-intercept, right? Y is equal to 1 minus 4, here 0, then 1 minus 0. It should be 1 because this is going to be 0. So 1 divided by 1 is 0. It's 1, sorry. So not this. So it's 1. We're okay now, right? So it's 0 comma 1. So 1 over 4 is here. Then 0 in y1. So 1 will put it there. So it's there. Yeah, now it's making sense. What it means here is that it's going to touch 2 points. Starting from this point, touching this point, again touching there, then going there. You put an arrow, you don't know where the graph ends. Once you do this, you reflect this part to the opposite part. The opposite of this is there. Then I reflect this just here. Simple. That's my graph. Any question? Any question there? Hello? Sally, is it making sense? It's making sense, eh? I want you to do the last question, then send me the answers before you sleep. Do this question for me. Now, the same issue, the same scenario, but what if we have been told that it is in the modulus? They're the same questions, but they're just in the modulus. So, for example, the first one here we said, do you want me to solve again, or maybe I should just give you the graph and then we see how we are going to do it? Okay. Napali Mayo. So now, here is the issue, guys. This one we also need to find the intercept. So to find the x-intercept, we agreed that y should be 0. So in this case, 0 is equal to, in the modulus, negative 4x minus 2, of which when I cross multiply here, we discover that if I remove the modulus, let's just remove the modulus, negative 4x minus 2, what will be my intercept anyway? Still is going to be negative 4 is equal to 0. So I'll have no x-intercept. That's what we said. Then that other one, to find the y-intercept, we said x should be 0. And then 0 is equal to, we are going to do what? Oh, x should be 0. We are trying to find the value of y, sorry. Y will be equal to the modulus negative 4, 0 minus 2, like that. So y will be equal to the modulus of negative 4 divided by negative 2 is what? The modulus of 2 is just 2. So when x is 0, y is 2. I'm done. Let's find the vertical asymptote. The vertical asymptote is that we said you get x minus 2 equal to 0, so for x will be equal to 2. The horizontal asymptote, the function is bottom heavy. The denominator on the degree of x on the denominator is higher than the degree of x on the numerator. Therefore, the horizontal asymptote is 0. Let's sketch now. I want you to understand me here. This is the principle of modulus. So the asymptote is at 2 and 0. 2 and 0. Then we have got a point where we have 0, 2. Where is 0, 2? In x 0, in y 2, which is here. So it is coming like that, going there. Initially, this graph has to be reflected opposite here. Okay? Opposite of that is here, like that. But it's a modulus, it can't go to the negative side. So what you do is you reflect this part here to the positive part, just here on top, meaning that the final one will be now this one. So you leave this one in dotted form, meaning you are telling them that this was the original graph. So you use a pencil. Okay? So you just reflect which is to the negative side to the positive part. Simple. That's all. Nothing more. Brown. Okay. Let's understand the second one. Then you are going to do the third and the fourth one. Initially, why can't we just do this one? It has gone already. Anyway, this one we said that we had the x-intercept. Do we have anyone who is writing? We had our graph for the third one, let's do the third one. If I, what was our horizontal asymptote? 1, right? The vertical, sorry. Then the horizontal was at what? 4. This question. Aika. Then we said that we had the 1 over 4 comma 0 and 0 comma 1, right? So 1 over 4 we said is somewhere here, this point, and 1 over 0 comma 1 is here. So we said this graph came from here, touching this point, going like that. Then we had to reflect this on top here. So all the part which is on the negative part, okay, the part which is on the negative part, reflect it to the positive part. Which part is that, if we are to see it correct? Which part is that? The question is, there is a modulus, meaning that any part which is on the negative part, reflect it to the positive part. So which part is on the positive part? That's my question. I'm asking, guys. Which part is on the negative part? That's the question. Hmm? Here, you just reflect this part. This part here is starting from the negative part from this point. So this, the whole of this down part here, you reflect it, it goes there. So it will go here, you put an arrow. Then you put this one in dotted form, clearing to show that that was my original. But because there is a modulus, it has penned, it has gone on top. So you just reflect it to the positive part. So I want you to go ahead and try this one and that one. We are good to go. Okay. So now before you continue, I want to show you how you can access the full tutorial sheet solutions and also some more practice questions and full topic videos on our site. So if you go to Chrome, then you go to your Chrome, then you search Transcended Institute, even just on Google. Okay, so if you search Transcended Institute, you'll be able to find this website here. So if you go on our website, you come here. So if you have got an account already, it's easy, but if you don't have an account, you have to create an account. And then I'm going to show you for mathematics. In this case, if I click on math, we have got math past papers. The first part here is just some introduction of sets, and then if you go down here, you'll be able to see the past papers for for mathematics. The videos, the past papers we solved, they are all here. Let me show you. If you come down here, then this tutorial sheet is for 1120. Then you have got the past papers for last year, both 1120 and 1100. We have got the full topic videos for set theory, then the functions. For example, if you want to understand more on relations and functions, like for the first question, you watch this video, 23 minutes. You want to understand more on one-to-one functions, you watch this video. The inverse function, composite function, basics of the function, domain and range of the function, then domain of the radical function, graphing radical function, domain of rational function, range of the rational function, how to find the x and y intercept, graphing function, rational functions, the piecewise function, the one we are from doing. The one we are going to do actually is question 7, I think 7 or 6, somewhere there. Completing square method, question the even and odd function, which is question 7 from this tutorial sheet. So it is very important for you guys to access these videos. They will really help you. Okay, so we also have some tutorial sheet here down. Then the question, the one we're solving for the application of radical function of the quadratic function is also here. You can also get it. We have got tutorial sheet for 1120, that is tutorial sheet 2, 3, and tutorial sheet 4. All the answers are here. So you'll be able to access all these tutorial sheet solutions at only 80 kwacha per course per month. So if you want to access all these videos, you can just get in touch with us using this number here, +2607 67 729927. So you'll be able to register with us. You just WhatsApp this number. So let's continue. So this is radical function, and we know that the first question we have been asked to sketch and also finding the domain and range. So how do we find the domain and range of the rational function or of a radical function? As long as a function has got a square root, that is a radical function. Okay, a radical function. How do you know that this is a radical function? The moment you see a square root, inside there is my x and y, that is a radical function. When you see a gamma function, there is a over maybe bx plus c. As long as there is a division here, then there is to my x down, even if on top there is no x, that is a rational function. Now we want to find the domain and the range of the rational function and the sketch. One thing we need to know is that you can never have the square root of a negative in the square root. It's not possible. That is undefined. Unless you go to complex number, that's when you'll be like, okay, this is the complex number, so I can say I need to add an I. But in this case, no. So to find the domain, get what is inside the square root, get what is inside the square root, equate it greater than or equal to 0. So I'll say x plus 1 greater than or equal to 0. So for x should be greater than or equal to -1. Meaning that my domain, this is the domain now. How we find the domain? Meaning that the domain is that it should start from -1 is included all the way to positive infinity. Or you can say x is such that x is greater than or equal to -1, but x is a member of all real numbers. That's the domain. Before I continue, who has questions on how to find the domain? Are you guys still here? Okay, so now that's the domain. Now how do you find the range? Finding the range, just come up with a simple coordinate. The condition is that x should be greater than -1. So you say -1, 0, then just put 3. Then start plugging in the values here. If we put -1, we are going to get 0. -1 plus 1 is 0. The square root of 0 is 0. Okay? Next, if I put 0, 0 plus 1 is 1. The square root of 1 is 1. I'll put 1 there. In fact, just here, before I even go to 1, it's okay, I can end there. What does it mean? It means that is starting from 0, it is increasing. Okay? You can see that it's 0, 1, meaning it keep on going. Therefore, y is greater than or equal to 0. That is my range. Now, how do you sketch? Okay, are we okay first before we continue? So my range will start from 0 all the way to positive infinity, 0 included. Meaning that sketching, I'm not going to have challenges because I've been told that when x is -1, then y is 0, meaning starting from there. When x is 0, y is 1. Here. So the graph starts from there, is going in that direction. That's my graph of that guy. Any question? Hmm? Any question? Okay. I'm not going to do part 2. You will do it because it's just the same as part 1. But I'll jump. I have to do part 3. Part 3, let's find the domain. 1 plus root of x plus 1. You are only when it comes for the domain, you are interested in the values of x. Get the ones which are in the square root. So x plus 1 greater than or equal to 0. So for x greater than or equal to -1. So the domain is that from -1 included, comma infinity. Or if you want, you can put it in Sage-Builder notation. X is such that x is greater than or equal to -1, but x has to be a member of all real numbers, like that. Finding the range is something which is very simple. You have to say xy. The condition is that x should be greater than or equal to -1. You start from -1. Okay? So when you put -1 here, what are we going to have? We are going to have 0. The square root of 0 is 0. Then 0 plus 1, which is outside here, is 1. I'll put it there. The next number is 0. If I put 0 here, 0 plus 1 is 1. The square root of 1, 1. 1 plus 1, 2. I'll end there. I don't need to waste time. So it's starting from 1, 2. It is increasing. Therefore, y should be greater than or equal to 1. So my range is that starting from 1 all the way to positive infinity. That's my range. Or you say y is such that y is greater than or equal to 1. Y has to be a member of all real numbers. Then sketching now. Sketching is something which is very simple because you have got your coordinate here from -1, then 0. In y you have got 1 and 2. So we have -1, 2 here. Next, 0 comma 2 there. Starting from this point, going there. That is our graph. As simple as that. I don't think you need to have problems here, because if we have got this question here, there is negative outside. Maybe that one can give you question problems. But what we have done here is exactly as what we were going to do there. Just get what is in the square root, which is x. X is greater than or equal to 0. That is your domain. Put the my coordinate. Find the range. Sketch. Done. Do that one. Give me the answer. You also do this one around. So, but me, I'm going to solve for you this one. So I'm going to solve the number 4 one, which is f of x is equal to neg the square root of x minus 2. So get what is in the square root, guys, greater than or equal to 0. So for x greater than or equal to, I shift this one to the other side 2. Therefore my domain is that from negative 2 included, or from 2 not negative 2. From 2 included all the way to positive infinity, or putting this in set builder notation is x is such that x is greater than or equal to 2, but x is a member of all real numbers. How do you find the range? Come up with just two coordinates, that's all. I'll start with 2. Next, I can put 3. If I put 2 here in the where there is x, 2 minus 2 is 0. The square root of 0 is 0. 0 times negative outside here is just 0. I'll put 0 there. 3 minus 2 is 1. The square root of 1 is 1. 1 times negative outside is negative 1. I'm done. Now, you can clearly see that you're starting from 0, then negative. Meaning that y should be less than or equal to 0. Starting from 0, but it is going down. It is not increasing, it is decreasing. When it comes for the graph now, the moment you have got this coordinate, in x you have got 2, 3. So 2, 3. In y is 0 and negative 1. I'll put neg 1 here. So the first one is 2, 0, which is this point. The second one is 3, neg 1, which is here. So the graph is going like that. But don't forget to put an arrow, because we don't know where it is ending. That's my graph of f of x is equal to negative x minus 2. Guys, for radical functions, I don't think you have got problems now. And this is where I rest my case, unless you have got questions. So we have done rational function and radical functions. So I'm going to post the recorded class. You'll be able to access it today. Thank you.